Have you ever wondered what whispers through the silence of the cosmos? What secrets linger in the vast stretches of time and space, patiently waiting for someone to notice? Tonight, let us drift together into a question that has haunted humanity since we first looked upward, eyes tracing the paths of stars. What if we are not the first? What if before us, long before the rise of cities, empires, and empires' shadows, there was someone or something that glimpsed the same skies, felt the same winds, and carved meaning from the patterns around them? We are perched on a pale blue dot, a planet spinning quietly around a modest star in a vast, uncharted universe. Each rotation, each orbit, each cycle of life seems ordinary until we step back, until we let ourselves float in thought, untethered from daily urgency. And in that suspension, we realize, perhaps Earth itself is a story written in rocks, rivers, oceans, and genes. Perhaps it carries a memory not just of our ancestors, but of others who came before, whose footprints may no longer be visible, yet whose echoes remain embedded in the patterns of the world. Imagine standing in a desert at night, far from city lights, where the sky spills 1,000-fold above you. The constellations, frozen for millennia, move only in perception. You might feel small, but what if those stars aren't just distant suns? What if they are markers, remnants, or even messages from civilizations whose curiosity rivaled our own? Every shift in the cosmos, every alignment of stone, every relic buried under layers of time might be a clue. And as our minds stretch to hold the vastness, we begin to sense a continuity, not a straight line, not a tidy story, but a flowing thread connecting past, present, and possibility. Curiosity has always been our compass. From the earliest humans, gazing at the sky or the flickering light of fire, to the architects of megaliths, the mathematicians, the storytellers, and the philosophers, there has always been a longing to understand not just the how but the why. Why are the stars ranged as they are? Why does life flourish in this corner of the cosmos? Why do civilizations rise, flourish, and vanish? The questions are not simply academic. They resonate in our bones. They stir something both ancient and immediate. Tonight, we will wander through those questions. We will trace the footsteps of thought across centuries, explore the edges of knowledge where science meets philosophy, and stand at the threshold where reality itself begins to feel like a story unfolding. We will look at the world as though seeing it for the first time, a living, breathing system that might carry hidden architecture, subtle hints, and extraordinary coincidences. And as we move together through time, from the myths of first civilizations to the algorithms of artificial intelligence, from the cycles of evolution to the contemplations of consciousness, remember this: the journey itself matters. Perhaps we are not here to find definitive answers tonight. Perhaps we are here to feel, to imagine, to recognize the astonishing fact that we exist in a universe capable of sustaining curiosity, wonder, and reflection. So let us begin. Let us lean into the questions that drift like starlight, gentle and persistent, through the dark. What if the first civilization left us clues all over Earth? What stories might they have woven into the rivers, the stones, the architecture, the patterns of life itself? And more importantly, what do those echoes tell us about ourselves, about our desire to know, to discover, to reach beyond the limits of our understanding? Even as we sleep or think quietly under the canopy of the cosmos, long before the hum of machines and the light of cities, humans looked upon the world and sought to understand it. They saw the sun rise and set, the moon wax and wane, and the seasons ebb and flow. And they asked themselves, what forces guide these movements? What invisible hands shape this unfolding drama of life? In those early moments, knowledge and imagination were intertwined. To them, the mountains were not just stone, the rivers not merely water, and the storms not simply weather. They were the voices of unseen powers, expressions of will, perhaps even messages meant to be interpreted. Across continents, diverse civilizations emerged, each leaving traces of their quest for meaning. In Mesopotamia, scribes etched cuneiform onto clay, recording events and beliefs that linked humans to the whims of gods. The Egyptians, with their towering pyramids and celestial alignments, embedded knowledge into stone, a testament to precision and foresight. The Indus Valley civilization planned cities with remarkable symmetry, hinting at a grasp of organization and utility that exceeded mere survival. And in Mesoamerica, astronomers charted the movements of Venus and the cycles of the sun, linking their calendars and rituals to the rhythm of the cosmos. What drove these achievements? Was it purely necessity, the hunger for resources and survival? Or was there something deeper, a longing to mirror the universe in human creation, to grasp the patterns that governed life itself? Perhaps the earliest thinkers recognized what we now call order, regularity, structure. They may not have had microscopes or telescopes, but they could see repetition, the predictable rise of the Nile, the sequence of lunar phases, the cycle of birth, growth, decay, and death. And with regularity came the instinct to ask why. In these cultures, the world was alive with agency. Gods were not distant abstractions. They were participants in daily life. The wind that carried seeds to fertile ground, the river that nourished fields, the sun that warmed skin and soil, all were manifestations of intention. Favor and punishment were woven into natural events, and to understand them was to navigate the delicate balance of existence. Life was not random. It was a tapestry of interactions guided by purposeful hands, whether divine or ancestral. Yet alongside this sense of intentionality was an emerging awareness of systems, patterns, and cause. Greek philosophers began to ask questions that transcended myth. Pythagoras saw mathematics as the language of the cosmos. Plato imagined ideal forms behind the objects of the world, and Aristotle sought natural explanations for phenomena without immediately invoking the divine. These thinkers began to tease apart the threads of observation and interpretation, planting seeds for a methodical inquiry that would take centuries to flourish. Eastern traditions offered another lens. The Vedic texts of India, Taoist writings of China, and Buddhist contemplations of impermanence all recognized a subtle order underlying reality. The world was seen not as a static creation but as a living, unfolding process, where harmony and balance governed change. In these perspectives, understanding the cosmos meant attuning oneself to rhythms, cycles, and flows, rather than imposing narratives of power or morality. What unites these early civilizations is the same curiosity that drives humans today, across time and geography. They asked, where did we come from? And how are we connected to the larger universe? Their answers were embedded in rituals, structures, myths, and philosophies, clues left not merely for their contemporaries, but for generations to come. And while we may now interpret their works with the tools of modern science, the essence remains the same: a desire to find meaning in complexity, to discern order amid apparent chaos, to glimpse the invisible forces that shape life. Even now, as we walk through the ruins of temples, pyramids, and observatories, or decipher texts inscribed on stone, clay, and parchment, we feel a quiet resonance. These civilizations speak across millennia, reminding us that humanity has always been drawn to the mysteries of existence, always seeking a bridge between the tangible and the transcendent. They hint at a continuity, a lineage of thought and imagination that perhaps stretches back even further than we can currently trace, a lineage that may include the first civilization, the hidden progenitors of knowledge, whose traces are still embedded in the earth, waiting to be discovered. And so, as we ponder these ancient worlds, we begin to sense something remarkable. The impulse to design, to understand, to encode knowledge into the environment is not uniquely modern. It is deeply human, perhaps even universal. From the alignment of stones to the patterns of stars, from ritual to mathematics, from myth to early philosophy, there is a persistent thread, an acknowledgement that the universe is structured, that patterns exist, and that noticing them is the first step toward comprehension. In the quiet of the past, among ruins and relics, we hear echoes of curiosity, ingenuity, and wonder. These civilizations, now distant, may have left clues not just in physical artifacts, but in the very way humans continue to question, explore, and imagine. Their legacy is subtle, like a pattern in the wind or the spiral of a shell. And as we begin to trace these clues, moving from the tangible to the conceptual, we are drawn inevitably toward the next chapter, the transition from myth to empirical observation, from divine explanation to scientific inquiry, a journey that continues to shape our understanding of the universe today. As civilizations evolved, so too did the ways humans sought to explain the world. The shift from myth and story to observation and reason was neither sudden nor complete, but gradual, a quiet revolution unfolding over centuries. While ancient peoples saw purpose and intention behind storms and seasons, thinkers began to ask questions about mechanisms, patterns, and predictability. What if the sun rose not because a deity willed it, but because the earth moved in a precise orbit? What if rivers flooded not from anger, but from measurable forces? The Greeks laid much of the groundwork. Thales sought natural explanations for celestial phenomena. Pythagoras and his followers explored mathematics as a universal language, and Aristotle catalogued flora, fauna, and physics, striving for principles that could describe behavior consistently. Observation became the lens through which understanding emerged. The world was not merely a stage for gods. It had rules, constraints, and rhythms that could be discerned, measured, and predicted. Yet, early science did not entirely discard the language of intention. The idea of a prime mover, an intelligent cause underlying existence, persisted. Nature's order was interpreted as evidence of design. Even as empirical methods grew, the Renaissance and Enlightenment saw thinkers like Galileo, Kepler, and Newton blend observation with philosophical reflection. The planets moved in predictable orbits, yet the elegance of their motion inspired awe, and Newton himself spoke of a universe shaped by both law and beauty. Here, science became a bridge, a method to reveal the architecture of reality, without denying the possibility of something beyond comprehension. The 18th and 19th centuries accelerated this transition. Experiments, systematic observations, and statistical methods replaced anecdote and superstition. Biology, chemistry, and physics began to reveal underlying principles. Organisms adapt, elements react in consistent ways, energy conserves, and matter transforms. But the emergence of Darwinian evolution brought perhaps the most profound shift. Natural selection described life as adaptive and emergent, not teleological. Complexity did not require intention. It could arise through variation, filtering, and accumulation over time. The elegant patterns of organisms, the eye, the wing, the spiral of a shell, could be explained as outcomes of iterative processes, rather than divine crafting. This was not a rejection of awe or beauty. On the contrary, the realization that complexity could emerge without foresight deepened it. Order could rise spontaneously. Life could innovate without a mind guiding it. DNA itself, a molecule of staggering intricacy, revealed how information, replication, and mutation could generate astonishing structures. The notion that structure required conscious design began to blur. Nature, it seemed, could simulate intention, yet remain entirely impersonal. Physics followed a similar arc. Classical mechanics described predictable systems, but as the 20th century approached, the quantum world and relativity challenged intuition. Particles were probabilistic, spacetime flexible, energy quantized. The universe no longer seemed entirely determined. It was dynamic, subtle, and at times paradoxical. Yet within this uncertainty, structure persisted. Forces acted consistently. Patterns emerged from randomness, and laws operated universally. The scientific perspective shifted from asking who designed this to how does this function. Observation became an act of listening to the universe itself, discerning the rules embedded in matter, energy, and interaction. And through these developments, humans began to see that design and emergence might not be mutually exclusive. Systems could appear intentional, yet be self-organizing. Complexity could arise from simple rules, whether in the genome, ecosystems, or planetary interactions. Feedback loops, thresholds, replication, and competition, all local processes, could produce outcomes that seemed global and purposeful. The distinction between artifice and nature, between invention and discovery, became increasingly subtle. By the mid-20th century, the tools of science had grown powerful enough to simulate these processes. Computational models allowed for experimentation on scales impossible in the physical world. Populations could be modeled, evolution accelerated, and ecological interactions tested in silico. Digital organisms evolved under rules not unlike those that govern life itself. Systems that were once thought to require careful design could now emerge from iterative interaction. Observing these models, one glimpsed the same echoes found in ancient thought: patterns, resilience, adaptation, and complexity. And yet, the shift to scientific thinking did not extinguish wonder. If anything, it amplified it. Understanding the principles behind a hurricane, a neural network, or a genetic mutation does not reduce awe, it reframes it. The universe, with its capacity for self-organization, for producing intricate forms without a guiding mind, remains as astonishing as the myths once told. Humans now recognize that the question is less about intent and more about mechanism, less about gods and more about processes, less about moral narrative and more about systemic consequence. The transition from myth to science, from story to observation, did not remove the human desire to ponder. It transformed it. The questions changed shape, but the curiosity endured. How does life emerge from chemistry? How do ecosystems maintain balance amid chaos? How does the brain, a mass of cells and sepsis, give rise to consciousness? And in exploring these questions, humans discovered a new form of poetry, one written not with words alone, but with the language of mathematics. physics, and biology. In this space, ancient questions meet modern tools. The desire to find patterns, understand causes, and seek meaning persists. And as science progressed, it laid the foundation for the next stage, the integration of technology, artificial intelligence, and simulations. For now, we recognize that the shift from religious and mythic frameworks to scientific ones represents not an abandonment of curiosity, but its refinement that allows humans to explore complexity, emergence, and the hidden architecture of the universe with tools both empirical and imaginative. As the centuries unfolded, human ingenuity took another transformative leap. Technology, machines, once simple tools, grew into extensions of thought itself, enabling the manipulation of matter, energy, and information on scales previously unimaginable. The Industrial Revolution mechanized labor, the Digital Revolution mechanized knowledge, and now the age of artificial intelligence mechanizes insight, pattern recognition, and creation. Through these developments, humanity began to probe not just the world outside, but the principles that govern intelligence, adaptation, and emergent order. Artificial intelligence, long relegated to the realm of speculation and science fiction, has become a mirror to the patterns we see in nature. Neural networks, algorithms, and simulations echo the brain's architecture. Though they do not replicate consciousness, they process structure, discern patterns, and sometimes generate outcomes that surprise even their creators. A computer can simulate evolution, running thousands of generations in hours, producing digital organisms with behaviors reminiscent of life itself. Complex strategies emerge, not through foresight, but through iterative adaptation within constraints. The rules of selection, variation, and replication, once confined to biology, now operate in silicon as well as carbon. In this convergence of computation and biology, the lines between discovery and design blur. Humans design conditions, but the outcomes evolve beyond intention. An algorithm can compose music, paint, predict, or strategize without awareness. Yet the results often resonate with a sense of coherence, pattern, and even beauty. It raises profound questions. Does creating require understanding? Can structure exist without conscious oversight? If a machine produces a viable ecosystem, a functioning organism, or a work of art, is that design or simply emergence manifesting through new substrate? Simulations deepen this contemplation. Virtual worlds, from detailed climate models to digital civilizations, allow experimentation on scales impossible in reality. Populations fluctuate, ecosystems stabilize or collapse, and agents interact under defined rules. Feedback loops, competition, scarcity, and cooperation produce outcomes that feel organic. Complexity rises not from centralized control, but from local interactions, a principle mirrored in natural systems across scales. The echoes between natural processes and artificial systems suggest a profound universality. Simple rules, repeated over time and space, can produce astonishing order. Moreover, the capacity to simulate accelerates discovery. Experiments that would take millennia in nature are compressed into hours, revealing insights about adaptation, resilience, and emergent structure. Digital evolution often produces solutions unfamiliar to human intuition, effective, yet sometimes awkward, elegant in function but not form. These solutions resemble patterns observed in nature: spirals, branching structures, feedback cycles, and fractals. It is a reminder that efficiency, stability, and adaptability often guide form more than aesthetics or foresight. I also challenge his philosophical assumptions about creation. If machines can generate solutions without awareness, then intelligence and intention need not be prerequisites for complex outcomes. The question of agency expands beyond humans and deities to encompass the processes themselves. Emergence becomes a form of silent creativity, a natural force shaping form and function, without moral judgment or conscious aim. In this frame, design may not imply purpose, it may simply be the byproduct of systems operating under constraints, responding to feedback, and iterating through time. Technology amplifies reflection on human existence. As we create systems that evolve, learn, and adapt, we confront the same questions we once asked of the stars and rivers. How do complex outcomes rise? How do structures persist, adapt, or fail? What is the relationship between initial conditions and long-term result? And in seeing these patterns manifest digitally, humans gain new perspective on natural processes, bridging the gap between observation and creation, between science and philosophy. The integration of AI into our understanding of the world also highlights our own cognitive patterns. Algorithms are extensions of human reasoning, modeling the logic, assumptions, and biases embedded within us. They reveal not only the potential of technology, but also the contours of our own thought. In creating artificial agents that navigate complexity, we glimpse the architecture of problem-solving, adaptation, and emergent strategy not just as a technical challenge, but as a mirror to intelligence itself. Yet, for all its power, AI does not replace wonder, it reframes it. Observing a machine evolve solutions, discovering patterns emergent from simple rules, feeling the resonance of digital ecosystems with natural ones, invites reflection akin to staring at the night sky or contemplating a fossil. Technology becomes both lens and canvas, allowing humans to explore, extend, and even simulate the principles underlying existence. The digital realm mirrors the physical, the emergent, the adaptive, the unexpected, and the audacious-inspiring. In this way, modern technology and AI do more than solve problems. They extend our capacity to question, to model, to simulate, and to imagine. They amplify the human impulse to seek structure, to uncover patterns, and to wonder at the processes that give rise to life, consciousness, and order. The distinction between creation and discovery narrows. What emerges in these systems is not merely a reflection of human design, but a collaboration between rules, conditions, and time. And in witnessing this interplay, humans confront the deeper philosophical questions that have guided thought for millennia. What is the nature of intelligence, of complexity, of design, and of consciousness itself? From the emergence of intelligence to the unfolding of civilizations, human thought has continually returned to the same profound questions. Why are we here? What is the nature of consciousness? Does the universe harbor meaning, or is it indifferent? These questions are not easily answered, yet they shape the lens through which we perceive reality. Philosophy, in its many forms, has always sought to bridge observation and interpretation, logic and wonder, the measurable and the ineffable. Contemplating existence, humans quickly notice patterns that suggest order. The rising sun, the cycles of life and death, the orbit of planets all evoke a sense of rhythm and predictability. But order alone does not imply purpose. From the ancient Greeks to Eastern thinkers, humanity has grappled with the tension between randomness and intention. Plato envisioned a cosmos guided by forms and a rational mind. Laozi saw the unfolding of the Tao as an emergent harmony, not imposed from above. Across cultures, the impulse remains to find coherence in what seems vast, chaotic, or overwhelming. Existential inquiry extends beyond the natural world into the self. Consciousness itself is a marvel, a system capable of reflecting upon reflection, of perceiving patterns in patterns, and of questioning the conditions that produced it. Awareness introduces paradox. Humans can witness the universe and yet are subject to it, can create meaning while embedded in systems indifferent to it. In recognizing mortality, contingency, and fragility, humans are forced to confront both their power and their limits. Technology, particularly AI, reframes these questions in startling ways. If machines can exhibit emergent behavior without consciousness, then complexity does not necessitate awareness. Intelligence may not require intentionality. Structure may not require a mind. The philosophical implications ripple outward. If the universe itself operates as a self-organizing system, perhaps meaning is not imposed but discovered, emergent rather than authored. Observing these digital mirrors of life forces us to reconsider the nature of creativity, the necessity of purpose, and the boundaries of comprehension. Time deepens these reflections. Human life is fleeting, yet consciousness allows awareness of vast durations, geological, cosmic, and evolutionary time scales. The Earth endures changes we can barely perceive. Continents drift, species rise and vanish, climates fluctuate. The human mind, capable of grasping these scales, exists for but a fraction of them. Here arises an existential tension. Our significance feels simultaneously immense, in that we can reflect on the universe, and minuscule, in that the universe endures regardless of our awareness. These reflections naturally lead to questions of ethics and responsibility. If the universe operates largely without intentional design, what is the role of human agency? Are our choices meaningful? Philosophers have debated these questions in countless forms. Some find solace in nihilism, accepting the absence of inherent meaning. Others embrace existentialism, proposing that meaning rises through conscious engagement, creative expression, and ethical action. And yet another perspective sees a participatory cosmos, where observation, curiosity, and learning are themselves threads woven into the fabric of existence. Existential inquiry also intersects with probability and contingency. The anthropic principle suggests that the universe permits life because observers exist to notice it. Yet this raises further questions. Why these physical constants? Why this structure? Why consciousness? Are these outcomes necessary, accidental, or inevitable? Philosophy and science converge here, both struggling to discern between chance and pattern, between randomness and hidden structure. Every observation becomes a reflection not just of what exists, but of the conditions that allow observation itself. In confronting these questions, humans often rely on analogy, metaphor, and narrative. The universe is described as a clock, a machine, a network, a symphony. Consciousness is likened to a flame, a mirror, a river of information. These metaphors are not literal. They do not capture reality in its entirety, but they allow the mind to navigate the incomprehensible. They offer bridges between intuition and abstraction, between what we perceive and what we can imagine. Art, philosophy, and science all serve as complementary modes of exploration. While science explains mechanisms, philosophy interrogates assumptions, and art evokes the subjective, the experiential, the qualitative aspects of being. Together, they form a mosaic of understanding, each piece revealing facets of reality inaccessible to the others. And as humans probe deeper, whether into subatomic particles, neural networks, or the farthest reaches of space, the questions expand rather than contract, generating layers of wonder and reflection. Finally, existential contemplation is inseparable from the personal. Humans project narratives onto the universe, seeking meaning not only in the cosmos but within their own lives. Every action, every observation, every choice carries weight because consciousness allows reflection. The universe, in its immensity, may be indifferent, but within that indifference, humans create purpose, ethics, and beauty. The tension between cosmic scale and personal significance shapes thought, art, science, and philosophy alike. In summary, the philosophical and existential questions that have accompanied humanity from the dawn of awareness continue to evolve. The interplay between randomness and order, consciousness and structure, observation and emergence, remains at the heart of inquiry. Technology, AI, and digital simulations offer new mirrors, reflecting processes that parallel the natural world and extending our capacity to ask, to explore, and to imagine. These questions may never be fully answered, yet they enrich the human experience, framing a life not merely as survival, but as conscious engagement with a universe both structured and mysterious. Throughout history, humans have navigated two intertwined pathways of understanding, the empirical rigor of science, and the narrative, reflective depth of faith. These paths are often portrayed as opposites, yet they share a common impulse, the desire to make sense of existence, to discern patterns, and to seek coherence in the complexity surrounding us. Science asks how, faith often asks why, and where these paths meet, profound insights emerge, inviting contemplation beyond simple binaries. Ethics rises naturally at this intersection. Knowledge, without reflection, risks hubris. Belief, without inquiry, risks stagnation. By integrating science and faith, humans gain tools to navigate uncertainty responsibly. The awareness that the universe operates under rules observable and testable combined with reflection on human impact and intention fosters both humility and agency. We recognize our ability to affect ecosystems, influence societies, and extend life through technology, while understanding that these systems are embedded in larger, often unpredictable frameworks. This integration also manifests in education, art, and public discourse. Scientific literacy paired with ethical reflection encourages curiosity balanced with responsibility. Faith and philosophy, when informed by empirical understanding, can avoid dogmatism and embrace inquiry. The dialogue between evidence and meaning becomes a source of resilience, creativity, and innovation. Humanity learns to navigate between certainty and mystery, prediction and wonder, rules and values. In contemplating the cosmos, humans face two truths simultaneously. The universe is remarkably structured, and our understanding is necessarily partial. Science reveals mechanisms. Faith provides context. AI and simulations offer new mirrors, demonstrating that structure can arise from simple rules. Ethics, philosophy, and spirituality guide interpretation, reflection, and engagement. Together, these dimensions create a rich, contemplative tapestry, one in which curiosity, reverence, and responsibility coexist. Ultimately, the integration of science and faith does not resolve the mysteries of existence. It reframes them, By embracing both empirical observation and reflective narrative, humans can inhabit a space that accommodates uncertainty while fostering meaning. The universe can be studied, marveled at, and ethically engaged with all without requiring definitive answers. The questions themselves become tools for growth, reflection, and imaginative exploration. This interplay shapes not only our understanding of the cosmos, but our approach to life on Earth. It encourages attention to detail without losing sight of the whole, reverence for what is observed without demanding certainty, and creativity in navigating complexity. In a sense, science and faith together mirror the very systems they seek to understand, layered, interconnected, dynamic, and emergent, producing insights that neither could generate alone. Section 7. Reflective analysis of design and nature extended as we look outward to the cosmos, and inward to the cells that compose our bodies. The question of design and nature persists, nuanced and elusive. Design here does not imply a conscious hand guiding every molecule, but rather an intricate layering of patterns, feedback loops, and emergent structures that create coherence from apparent randomness. Nature, in its vastness, offers systems that seem purposeful, yet are shaped by processes that are indifferent, iterative, and distributed. Consider the human body, a network of organs, tissues, and cells operating in synchrony. The brain interprets and adapts, the immune system responds and learns, and the heart pulses tirelessly. There are inefficiencies, compromises, and vulnerabilities: the blind spot of the eye, the convoluted path of the intestines, the spine's imperfect adaptation to upright posture. These features are not failures of design. They are artifacts of an evolutionary process that favors survival, not perfection. Complexity is layered upon complexity, the old repurposed into the new, producing systems that are resilient, flexible, and capable of remarkable feats. Zooming out to ecosystems, the same principles emerge. Rainforests, coral reefs, and savannas are dynamic networks of interacting species, resources, and environmental pressures. Predators hunt, prey evolve, nutrients cycle. Disasters strike, species vanish, and yet life persists. This is not a flawless design, but a system that has endured through iterative adjustment. The environment is neither benevolent nor malevolent, it simply is, shaping the living through constraint, opportunity, and consequence. Survival itself becomes a kind of emergent design, a testament to the power of systems to self-organize. The patterns we observe, from the spiral of galaxies to the fractal branches of trees, from neural networks to river deltas, suggest underlying rules or geometries. They appear again and again, not because they were imposed, but because they emerge naturally from interactions constrained by physics, chemistry, and biology. Here, structure and function intertwine, offering efficiency, stability, and adaptability. The line between what appears designed and what arises spontaneously blurs. Complexity does not require a mind. It requires conditions that allow self-organization and iteration. Human perception, however, instinctively interprets these emergent systems as intentional. Our minds are wired to seek cause, to assign meaning, to recognize patterns even in randomness. This cognitive tendency has been critical to survival, allowing us to predict threats, locate resources, and understand social dynamics. Yet it also predisposes us to see design where none may exist, to infer intention behind natural processes that are indifferent to our existence. Technology mirrors these dynamics. In artificial intelligence and algorithmic systems, simple rules can yield behavior that appears purposeful. Neural networks, evolutionary algorithms, and simulations evolve solutions without understanding, guided by constraints and feedback. These emergent structures echo patterns in nature, suggesting that complexity, order, and even apparent creativity can arise without consciousness. Observing these parallels invites reflection. If artificial systems generate structure from rules, and natural systems do the same, what is the role of intention in the broader universe? Even within Earth's systems, randomness and order coexist in a delicate tension. Volcanoes reshape landscapes unpredictably, while tectonic plates drift with slow precision. Rivers carve valleys, glaciers sculpt mountains, and yet patterns emerge: drainage basins, sediment layers, and climatic zones. Life itself thrives within these shifting conditions, adapting, migrating, evolving. The emergent design we observe is a product of constraints, selection, and feedback loops operating across time and scale. From a philosophical perspective, design in nature can be reframed as a lens, rather than a prescription. The architecture of life is evident not in perfection but in persistence. Stability rises not from control but from iterative trial, adjustment, and resilience. Structures that endure are not flawless, they are robust, flexible, and capable of sustaining complexity in the face of uncertainty. Trade-offs are inevitable. Survival often outweighs elegance. Evolution, ecosystems, and physical laws favor what works long enough to matter, rather than what is ideal. The reflection deepens when considering human interaction with natural systems. Our technologies, cities, and social constructs overlay emergent natural systems, creating hybrid architectures where design and emergence coalesce. Agriculture reshapes ecosystems, biotechnology modifies genomes, and urban networks mirror ecological principles in traffic flows, resource management, and communication systems. We witness, and sometimes direct, processes that combine human intention with natural adaptability. In doing so, we become participants in ongoing cycles of emergent design, shaping and being shaped by the systems we inhabit. Ultimately, nature's design, whether interpreted as emergent, intentional, or a hybrid of both, invites contemplation. It is a design that is alive, iterative, and adaptive. It is a design that challenges the human craving for perfection, offering instead resilience, novelty, and interconnectedness. It reminds us that survival and awareness, rather than control, define the sophistication of a system. And in reflecting on these patterns, humans gain insight not only into the world, but into their own place within it. Observers, interpreters, and participants in a vast, dynamic network of structure, flow, and consequence. Design, then, becomes not a static blueprint, but a living conversation between chance and necessity, between constraints and creativity, between persistence and adaptation. The universe unfolds as a layered narrative of emergent complexity, in which we are both witness and actor. The systems of Earth, biological, geological, atmospheric, and social, demonstrate that structure and function, pattern and randomness, coexist in a profound balance, offering lessons that extend beyond the observable and into the philosophical, ethical, and imaginative dimensions of human thought. In the evolving dialogue between reality and imagination, the concept of simulation emerges as both tool and metaphor. Digital frameworks allow us to replicate the world, not perfectly, but in ways that reveal underlying principles and dynamics. In these parallel environments, whether virtual ecosystems, simulated economies, or artificial life, we observe behavior that mirrors the natural: emergence, adaptation, competition, and cooperation. The boundaries between the artificial and the natural blur, challenging assumptions about creativity, design, and agency. Consider a digital ecosystem populated by agents programmed with simple rules. Alone, each agent is limited. Collectively, they interact, compete, and adapt in ways that produce unexpected patterns. Over time, structures rise: networks, hierarchies, flows that were never explicitly coded but are inevitable consequences of constraints, and feedback loops. These emergent structures echo patterns in natural ecosystems, population cycles, predator-prey dynamics, resource distribution. The striking similarity forces a question: if rules and interactions alone can create complex, lifelike systems, how much of what we perceive as design in nature is emergent? Artificial intelligence accelerates this exploration. Evolutionary algorithms, neural networks, and generative systems simulate selection pressures at speeds far beyond biological reality. Digital organisms evolve in hours what takes nature millennia. They discover solutions, optimize strategies, and develop behavior that surprises even their creators. In some cases, these solutions resemble forms found in the natural world: spirals, branching networks, fractals, cooperative strategies. The resemblance is not literal imitation, but convergence, a testament to universal constraints, efficient forms, and systemic pressures. Parallel creation is not limited to biology. Cities, economies, and social networks are now simulated digitally to predict trends, test policies, and understand emergent phenomena. Agents interact under defined rules, revealing how small changes ripple through systems. Markets rise and fall. Networks form and collapse. Ideas spread like contagion. The simulations offer insights not because they replicate the world perfectly, but because they uncover the principles by which systems operate. They demonstrate that complexity can emerge from simplicity, and that the structure we perceive may result more from interaction than from a conscious designer. At the edge of this exploration lies the philosophical question: what is real? The simulation hypothesis posits that, if sufficiently advanced civilizations can create digital worlds, populated by conscious-like entities, then the odds favor our reality itself being a simulation. While speculative, the hypothesis is grounded in logic. The more advanced and numerous simulations exist, the more likely any observer, ourselves included, finds themselves in a simulated environment, rather than a primary one. This idea reframes existence. If the universe operates according to rules akin to computation, then studying those rules, rather than searching for a singular origin, may yield the most meaningful understanding. Even without assuming literal simulation, virtual environments reveal a profound truth. Structure and emergence are inseparable from the conditions that produce them. Constraints, feedback, memory, and iteration give rise to order that feels intentional, even when no conscious mind intervenes. Virtual worlds, like natural ones, contain inefficiencies, randomness, and unexpected phenomena, yet they also reveal resilience, adaptation, and stability. The parallel between digital and natural systems suggests a universality of principles: order from interaction, complexity from constraints, novelty from repetition and variation. In these parallel creations, humans occupy multiple roles: designers, observers, and participants. We define rules, yet the emergent patterns surprise us. We guide processes, yet we witness autonomy. The act of simulating becomes a form of philosophical experiment, probing not only what works but why, what structures emerge under given conditions, and what insights can be drawn about the universe and ourselves. Through simulation, we explore possibility spaces, generate alternative realities, and test hypotheses that would be impossible in the physical world. Artificial intelligence adds another layer. AI systems, trained on vast datasets and evolving through iterative feedback, produce creative outputs without consciousness. They write, compose, simulate, and predict, reflecting the structure embedded in data, patterns, and constraints. Their creations, while devoid of intention, often resonate with meaning to human observers. This evokes questions central to both philosophy and science. Must creation require understanding? Can meaning emerge independently of intention? Are we recognizing design where none exists, or uncovering structures inherent to the system itself? Parallel creation also reshapes our understanding of evolution and adaptation. In simulations, selective pressures can be adjusted, environments can be manipulated, and outcomes accelerated. We witness evolution compressed, revealing mechanisms and interactions hidden in natural timescales. Solutions that appear optimal or innovative emerge from constraints and trial, echoing nature's own processes. This interplay between human guidance and emergent behavior illuminates a continuum, from natural evolution to artificial life, from the spontaneous to the engineered. The philosophical implications extend further. If the universe itself can be understood as a vast, self-organizing system, then the line between simulation and reality, between design and emergence, becomes porous. Life, consciousness, and intelligence may be viewed as expressions of computational principles unfolding across scales, from quantum interactions to planetary systems, from neural networks to civilizations. The observer, too, becomes part of the system, influencing, interpreting, and participating in ongoing emergence. Through simulation, we see creation not as a static blueprint, but as a dynamic process: feedback and adaptation, constraints and possibilities, chance and necessity. We realize that the universe, digital or physical, may not require a singular designer to achieve complexity. Instead, systems evolve, adapt, and persist, giving rise to structures that appear purposeful and resilient. The act of observing, modeling, and participating in these processes mirrors the evolutionary principle itself. We learn by trial, reflection, and iteration. Parallel creation challenges our assumptions, inviting us to consider that structure, pattern, and apparent design are emergent properties of interacting elements, rather than imposed constructs. It reframes the philosophical question of purpose. Meaning may not precede existence, but arise from participation, reflection, and understanding. By building, simulating, and observing, we engage in a dialogue with the principles that shape reality, uncovering insights about life, complexity, and our own role in the unfolding story of the cosmos. As we step back from the cycles of life, the unfolding of simulations, and the layers of systems, the universe itself comes into view: a vast expanse, indifferent yet intricate, silent yet resonant with patterns. Galaxies swirl, stars ignite and fade, and planets spin in quiet harmony, each following rules that both constrain and enable. From this vantage, the story of Earth is a single note in an endless symphony, a fleeting melody in the cosmic rhythm. The questions that guided us about design, emergence, purpose, and chance expand to the scale of the cosmos. Are the laws of nature finely tuned for life? Or do we simply perceive patterns where chance reigns? Is the universe conscious of itself through us? Or are we the observers, alone yet aware, tracing structures that exist independently? These inquiries bridge philosophy, science, and contemplation, suggesting that our search for meaning is both personal and universal, even at the grandest scale. The principles that shape life on Earth, interaction, feedback, adaptation, echo in the movement of stars and the formation of galaxies. Complexity emerges where conditions allow, whether in the spiral of a galaxy or the sequence of a DNA strand. And just as digital simulations mirror biological evolution, so too does human awareness reflect the cosmos' capacity for self-observation. Ultimately, the question is not whether the universe was designed, discovered, or simulated. The question is how we live within it, how we observe, reflect, and participate. Every breath, every thought, every act of curiosity connects us to the vast systems around us. The night sky, the turning seasons, the fragile fossils buried in stone, they all invite us to pause, to wonder, and to engage. Perhaps the greatest insight is that we are both observers and participants in an ongoing process of emergence. We do not need certainty to appreciate the depth of what surrounds us. The planet will keep spinning, life will continue evolving, and patterns will unfold. Whether or not we fully understand them, our role is to notice, to reflect, to learn, and to be present. So here, at the edge of understanding, we rest, not in answers, but in questions, not in certainty, but in awareness. Whether Earth was designed or discovered, whether systems are intended or emergent, the world remains astonishing, intricate, and alive. And we, in our fleeting consciousness, are part of that wonder. Sleep, think, breathe. The planet will turn, the cycles will continue, and the questions, good, quiet, profound, will always be here for us to meet again.